At a small college, the ratio of the number of men to that of women is 9 to 4. If there are presently 13,000 students, how many additional women would it take to change the ratio of the number of men to that of women to 2 to 1? So what we have here is a middle school problem. I call it an arithmetic problem. Now you can use algebra to solve this problem, but I don't think you need algebra, or you need the introduction of variables to solve this problem. So we are going to solve this problem without using a bunch of variables. And why are we going to do it? So that we can really understand the concept and not just follow a bunch of rules that we can memorize and just somehow come up with an answer magically. So we are going to try to understand the whole concept of ratio in the context of this problem. So go ahead, if you want to solve the problem, solve it. And if you want to look at the solution, you can watch the entire video, but it's a good idea to pause the video and at least try to solve the problem on your own. So here's the problem in smaller font right here, and we're going to solve this problem using the concept of ratio. Suppose m is the original number of men and w is the original number of women. By the way, it may look like a bunch of variables, but we are not going to construct an equation to solve. So the original ratio of the number of men to the number of women was 9 to 4. So that tells me that out of all the students, if you divide all the students into 9 plus 4 or 13 equal groups, 9 groups will belong to the men and 4 groups will belong to the women. Another way to look at it, if you divide all the men and all the women into equal number of groups, and 9 of those groups will be all men and 4 of those groups will be all women. So if that's really the case, so what does that really mean? According to the question, all these students, 4 groups of women and 9 groups of men, should add up to 13,000 students. Why? Because the question says that there are 13,000 students in that college. Okay, if that's the case, we can find out what each box or each group is worth. So we take 13,000, and let's do it here. We take 13,000 and divide it by 13. Where's 13 coming from? 4 groups of women, 9 groups of men. And what does that turn out to be? That turns out to be 1,000. So each box or each group contains 1,000 women or 1,000 men, depending on which group you're talking about. So there are 9,000 men in that college and 4,000 women in that college. So that's what we can conclude from this ratio and the fact that there are 13,000 students in that college. Now, we want to change the ratio. We want to invite more women so that the ratio of men to women is 2 to 1. So from the previous slide, we concluded that originally there were, or are, however you want to visualize it, originally we had 9,000 men and 4,000 women. Now we want to change the ratio of men to women, and we want the ratio to be 2 to 1. Now we want to invite more women. So how do we do that? Now take a look at this. We are not changing the number of men. We just are trying to invite more women. So if I have 9,000 men and I want to invite more women so that the ratio is 2 to 1, if I have 9,000 men currently and I'm not changing it, so the new ratio will be men to women. The new ratio will be 2 to 1. Well, if I have 9,000 men, I need half of 9,000, which is 4,500. So I have 9,000 men. This is still 9,000. Let's write 9,000 here. And I want half of that to be the total number of women, which turns out to be 4,500. So I have 4,000 women in the college. How many additional women do I need? I only need 500 additional women. So my answer is 500. 4,000 and 500 minus 4,000 is equal to 500. So I need 500 women. Once I recruit 500 more women, the ratio of the men and women would be 2 to 1. This is the new ratio if you're taking notes. New numbers, new ratio. That's my answer, 500 women. Here's a parallel problem that you can try. The answer to the question appears below the video in the description area.